So in section 10.2, I first want to show you guys where the equation for a trapezoid comes from. Okay? And you can just follow along with this if you'd like, or you can write it down somewhere in your notes if you'd like to as well. So we start with the trapezoid. And you guys already know something about a trapezoid, particularly that it has one set of parallel sides. That's what makes a trapezoid a trapezoid. Okay? So I don't particularly know, or currently know, the area formula for this trapezoid. So I need to figure some stuff out. First things first, I need to talk about some side lengths. The parallel sides of a trapezoid are what we call the bases. Now, there are two different lengths, right? So we have base number 1 and base number 2. Does it matter which one you call number 1 and number 2? No. That part does not matter. So we have our two bases. Okay, well, the next thing I want to do then is I want to go ahead and say, well, if I don't know how to find the area of a trapezoid, let's see if I can turn it into something I do know. For example, I know how to find the area of triangles. And I can draw one diagonal in here and break this guy into two triangles. Okay? So I now have two triangles. I know that the area of a triangle is 1/2 base times height. So the area of this trapezoid is going to be 1/2 base times height plus 1/2 base times height. The area of my two triangles added together. Okay, so looking at my first triangle, which is the one there kind of on the bottom left, I'll call that my first triangle. To find its area, I would take 1/2 times its base, which in this case is base 2, times its height, which I don't have marked up there yet. But the height would go from this vertex perpendicular to the opposite side, right? Perpendicular to that base. So that would give me my height. So there's the area of that bottom triangle. Let's take a look at the second triangle. I'd have 1/2 times, well, we're going to use B1 as its base. Okay, base number 1 as its base, because of course we're trying to get the area formula for a trapezoid, so we better use those as our bases. And because we have parallel lines, the height for that second triangle would be measured here, right? Perpendicular to that base. But isn't that height going to be the same as the height we used for the first triangle? Because those lines are parallel, right? Think of them as train tracks. Train tracks have to be the exact same distance apart everywhere. Otherwise, bad things happen, right? So, same thing here. Parallel lines, the distance between them will be the same. And so the height for that second triangle is still h, meaning it's the same height as we used for the first triangle. It's not h sub 1 and h sub 2. It's just h. It's the same number. Okay? So I now have this. All right, well now I want to do a little math magic here. And I want to factor out what I know is the same. I know that the 1/2 shows up in both equation. I know that the h is the exact same number. And so I am going to factor 1/2 h out in front. If you remember factoring from Algebra 1. If I factor out 1/2 h, what's left behind? b squared, b sub 2 plus b sub 1. Which is then, of course, the equation that the book is giving you for the area of a trapezoid. Now, I happen to be someone who learns things by patterns. Okay? I learn things by patterns. And so every equation we've used so far has been base times height, base times height, base times height, or 1/2 base times height. Okay? Well, I prefer, for me, whether you agree or not, doesn't matter. You can do what you like. If you like the way the book does it, do it that way. If you like what I'm going to write down, do it my way. But I prefer to use it as 1/2 times b sub 1 plus b sub 2 times h. because I still like to have base times height. Okay? It just helps my brain stay organized. All right? And so, there we go. The area of a trapezoid, its formula is really just derived from the area of a triangle. Questions? So taking a look at your notes, we will start by finding the approximate area of the state of Nevada. The state of Nevada is roughly a trapezoid. Okay? The state of Nevada is roughly a trapezoid. And its western border is approximately 250 miles. Its eastern border is approximately 511 miles. The distance between those two borders is approximately 309 miles. So, to find the area of Nevada, since it's roughly a trapezoid, that's the formula we would use. Area equals 1/2 times b sub 1 plus b sub 2 times h. And I want to plug in. So I have 1/2 times 205 plus 511 times my height between those bases is 309. All right, so we have 1/2 times 716 times 309. Grab that handy dandy calculator, and we are taking 0.5 times 716 times 309, and that gives us 110,622 square miles. Questions? No? Pretty straightforward, just a new formula to plug into, right? Okay, well, let's take a look at another example, the one right next to it. In this example, again, we just have a trapezoid, so that's great, no big deal there. Area is going to equal 1/2 times b sub 1 plus b sub 2 times h. Okay? And we could plug in some of this. We know that our area is going to equal 1/2 times 5 plus 7, but we don't know the h. Okay, we don't know our height, so we have to find that first. They don't give it to us. And the nice thing about this problem, though, is that they do give us a little bit of help. We have a right angle here, so therefore the height would really be this side here, right? If we knew it, okay? But what I could do is draw a segment here that is also perpendicular, making now a rectangle and that triangle. I can do that now because they give me that 60-degree angle. That is helpful. We learned way back when a little something about 30, 60, 90 triangles. Okay? We learned that all 30, 60, 90 triangles are similar to this triangle. 1, square root of 3, and 2. So, we need to come in here and set up a proportion to solve for our missing lengths. So let's see, we start with 1, we have the square root of 3 in the middle, and 2 on the end. And looking at our triangle we have, do we know any of those 3 sides? Well, yes, we do. We happen to know the length of this side of our triangle. Right here. Why? Well, because on the right side, that's a rectangle. So that means that segment there is 5 meters long. But if the entire distance from P to Q is 7 meters, then this part must be 2 meters. Right? Okay. Well, that part is opposite the 30-degree angle. This must be a 30-degree angle if that one's 60 and this one's 90. And so opposite the 30-degree angle is where the 1 is in our 30, 60, 90 triangle. And then, question? Okay, so we are looking for this height right there. What side of that right triangle is that? Is that a leg or is that the hypotenuse?
Leg.
That's a leg. Line segment PS is the hypotenuse of that triangle. And so therefore, I don't care about that part of my proportion because I'm not trying to find the hypotenuse. I'm trying to find the other leg. Okay? That other leg is going to be my height. So, if I cross multiply, I get h equals 2 square root of 3. H equals 2 square root of 3, which I can then plug into my equation. And by the way, I could have found that out without setting up the proportion. Okay? Some of you practice these special right triangles enough to know that if it's going to be 1, 2 square root of 3 down here for my basic triangle, well now if the short leg is all of a sudden 2, everything in that basic triangle just doubles, right? It's now going to be 2 square root of 3, and 4. Okay? So yeah, you could do it that way. All right, so real quick here, we have 1/2 times 2, they cancel out. Our area is going to be 12 square root of 3 square meters. Give exact answers if possible.